So it's my great honor to introduce our keynote speaker that is going to have the last few words of the conference, hopefully the most interesting as well, given the topic. Professor Bill Megginson is one of the most cited finance professors. He has done a lot of work on privatizations, on IPOs, on private equity and venture capital. And very recently, he decided to focus his energy and attention on the space economy and how private equity contributes to that economy. Professor Bill Megginson is from University of Oklahoma. He's a chair professor in finance. Thank you so much for joining us. Thank you.
I'm Bill Megginson. Thank you very much for inviting me. I'm honored to be here. As a little background, how did it come about, Final Frontier and Spaceflight? About 3 years ago, either I volunteered or I was volunteered to develop a course on spaceflight finance for the aerospace and defense program at the MBA program at the University of Oklahoma. How hard can it be, right? I had been teaching venture capital for a long time, private equity, just, look, that's what most of it is. And surely there is an industrial organization model, economic model of the space industry. There's not. So basically what I've tried to do, and what the outcome of this course has been to try to put some kind of economic framework about it and do it from a finance point of view. So this is the background of how I came to be involved with spaceflight finance, and it's absolutely fascinating. So hopefully I'll convince you of the importance of this, and hopefully I'll enlist some help. This is a fascinating topic, but I'm very lonely. We don't have very many people who are doing this. So if you're an academic and you're looking for a topic, hopefully I'll make this worth your while. So some of the key findings, just an overview. The second one, they're bold, because this is what really surprises everybody when they see this. You think of the space industry, the space economy, as overwhelmingly government. No, over 3/4 of it's private. Contracting between private companies, private investment, only 1/4 of it, and a declining fraction is government contracts. Still important, still vital, but it's overwhelmingly a private business. It's mostly financed through, government contracts are important, but only about 6% of SpaceX's revenues come from NASA, overwhelmingly private. So, and the Apple capital comes from venture capital and private equity. And I'll show you the vast majority of it. If we think about this, the space industry, it's satellites. 80% of it is satellites. Getting them up there, using the data that you get from them, it's overwhelmingly satellite business. The most important business, the most valuable publicly traded space company, Uber. What? But just think about it. Uber could not exist without GPS. The DoorDash, these companies, the positioning, timing, navigation companies, could not exist. They are space companies. Now, what's going to become by far the most important is what's going to happen later this month or next month with the IPO of SpaceX, by far the largest IPO in history. This is what's coming, and this is an industry that's dominated by one company. The growth of this industry is supercharged by the decline in launch costs. I'll have a slide on this, but I love history. I always have, and many of us probably do. Think through history of major declines in transportation cost. All the way back to the Middle Ages, where you went from oxen to canals, barges, or when you went from airplanes, went from propellers to jets, this massive reduction in transportation costs. This is what's happened in the space economy and what's driven it. This is a major industry with exactly one internationally agreed treaty. The Outer Space Treaty of 1967, almost 60 years old, is the only universally agreed treaty law governing the space industry. Think about aviation or telecoms and the whole architecture of regulation and laws. There's one. I'll refine that a bit. The militarization of space, I wish I didn't have to talk about it, but it's always been there. It is continuing. It's accelerating, but it doesn't necessarily have to be catastrophic. So I'll talk about that. Private companies, since SpaceX is still private, dominate in terms of valuation, almost $2 trillion total value of private companies. Public companies, $600 billion, of which Uber is the highest. Until very recently, the financial returns, this is where venture capital has gone to die. Until very recently. Far more money has been lost in space companies than has been created, and I'll show you that. And then finally, we'll talk about some of the things that are coming, some of the future of space. So first off, what is the global economy, and what are its segments, and how big is it overall? Well, it turns out it's about 612 billion down there. Space report, they stopped doing it, but they used to update it every year. But the key thing here is to notice the ones in blue, those are private. So the single biggest is going to be in the second row there, second column, position, navigation, and timing. That's GPS. This is the biggest, by far, so far, the most important economic industry that's come out of the space business. Launch, overwhelmingly SpaceX, but a few others. And then you come down here, and the US government budget is $77 billion, $55 billion for everybody else. I'll have a slide for this in a second. And one of the things that you'll see is that this is overwhelmingly military. Governments spend a lot of money on space, but it's overwhelmingly military and reconnaissance, and that's increasing. Okay, now, again, we're all finance professionals, so we know that across country, across time, across industries, businesses raise capital in two ways. Primarily, internal cash flow. Second, when they go external, they do debt, right? Bonds. Not in space. You can't do it. So in space, it's a very hard industry to finance. One, you're raising capital all the time, and you're having to, there's a very tight connection between investment and acquisition, and you're always cash poor. You've got this tremendously long development cycle. You're raising bespoke, highly technical, obsoleting equipment that you have no idea whether it's going to work or not. You're dealing with governments, in many cases, at the start stage. So your liquidity management is a big concern. You can't use debt, right? If you can't collateralize an asset, you really can't use debt. If you don't have an established secondary markets, you can't use debt. We know this from finance theory. And so there's very little debt. What you have is usually acquisition debt. No leasing. Of all the research I've done for 3 years, I have never seen the term leasing being used, which we know in other capital-intensive industries is tremendously important. Doesn't happen. No financial engineering. You don't have the stable cash flows to do any of that. On top of that, the people that you have involved, the entrepreneurs, these are very type A individuals. So they're very strong entrepreneur founders who have very strong opinions. Almost always, somewhere in the background is government with its own set of rules and regimens. So this is a very strange industry to be doing finance with. And how do you pay people, right? You need to get really, with the theme that I've heard today, importance of the best people. Well, the best aerospace engineers are really expensive. They have a lot of options. How do you keep them on board when you don't have any cash? You pay them in equity, right? So the importance of options is overwhelmingly important here, and so far there have been very, very few IPOs. I'll have that to show. Okay, how is it financed? The space economy, overwhelmingly two things. Government contracts, now they're a small fraction of the total aggregate, but they're critical. They're almost always, even SpaceX, it was critical in the early stage to get the contracts with NASA. So government is although it's not dominant, it's very important, particularly in the early stage. Okay, this is government spending. It's 2024. 2024 was 135 billion. It's probably over 160 billion now. And if you look at it, the US is going to be on the left almost 80 billion, 79.7. China, by far the next largest, around 20 billion. Japan, 6.8. Europe, total, 6.7. Russia, 4. This is the distribution. Of that, well over half, 55 to 60%, is military. Military, reconnaissance. This is a heavily militarized industries. Now, this is, if you're at all interested in this, and this is a private equity conference. So Space Capital is a venture capital firm started by an American, but he got his degree, MBA from Oxford, and started this fund. But what really is the important thing from Space Capital, is their data providers, and they write a quarterly report. And what this shows is the amount of capital, private equity capital. Think about how rare that is, that you have an industry with this kind of heavy representation of private equity capital. Not all venture capital, there's a lot of private equity as well, but overwhelmingly private equity that has done this. 455 billion since 2009. If you look, 2025 was a record year, 59 billion. But the first quarter of 2026, one quarter, was $36 billion. So this is on a tear in terms of the capital that's being raised. Where does it go? This is of the 455 billion. You can see 59%, about 60% in the US, about 20%, 19% in China, and then 3% in Singapore, India, and Britain, UK. Singapore's probably sovereign wealth funds, but I haven't been able to nail that down. Where does the money go? The middle circle, 85% is satellites. Satellites are the business of space. Launching them, servicing them, and then taking the data use from it, selling that. Okay, this is the value. One of the other things that Space Capital does is they give you a private valuation. What's wrong with this picture, right? This is 1.8 trillion total. Overwhelmingly, this part right here, I wish I had a pointer, that's SpaceX, 1.25 trillion. Now, a little bit later, I'll show you, at the end of 2024, it was 400 billion. So it tripled in a little over a year. Then over here, Blue Origin, a little bit on the corner there, and then the other sectors. But it's overwhelmingly SpaceX and overwhelmingly infrastructure. Okay, this is just, I picked out the largest deals just from the first quarter, this extraordinary first quarter. And how often do you see a $1 billion seed round? Intuitive Advanced Machine Intelligence, the Waymo, this is artificial, autonomous driving. How is that a space company? It's completely GPS, right? So this is the largest investment ever in a venture capital investment in a space company, 16 billion. What was the largest, the iSpace down here for China? That's the largest venture capital investment in a Chinese private company, venture capital company, space company. So venture capital investment in space is on a tear. Now, we all know that we've all seen this in one form or another, the graduation rate from one round of venture capital to another. The classic one in the Journal of Finance, as I remember, something like this, but by the time you get down to the fifth tier, Series D, E, or they had an exit, it was about less than 10%. This is far lower than that. Now, this doesn't show all the exits, but you can see for the infrastructure, 1%. So this has been a very high failure rate over time. And it may be improving slightly, but also a whole lot of money is coming in. Okay, the launch industry. Ultimately, this is the bottom line, the base of it. Without a solid launch industry, nothing else happens. And this has been revolutionized. So these are the orbital launch attempts by country for the last 4 years, since 2022. So you can see, let's just go to 2025. 181 was the US, of which 162 or 3 was SpaceX. Then you have China, 92. 19 of those were private. The rest were CASC, the government. Then 17 for Russia and 17 for New Zealand. New Zealand, that's probably Rocket Labs, which is an American company now, but it started in New Zealand, still does some launch. Europe is 8. Before that, they were 3. So a bit of a lag. This is the totals. And you can see that still the record for the total number of space orbital launches is Russia or the Soviet Union. But it's the same rocket. Basically the same rocket that went sent Soyuz up with some modifications is what they're using now. Now it's basically US and China. In 2026 already, through early March, we had 104. So well on the way to another record year. Just SpaceX alone was over half of the launches. Over 80% of the total tonnage put into space is by this one company. Several recent major innovations by India, of all countries. India has done a very successful space industry on the cheap. They did landed a probe on the south pole of the moon, where the water and the sun is, for $74 million. You know, this is basically gets you to the planet, gets you to the launch pad in any of the West. China, you've had first successful private landings. You finally had Ariane 6 by the European Space Agency, many years late. And you've had the second company to actually reuse a rocket. Now, when all said and done, what makes SpaceX so successful is they have reused the rocket, the first stage that sends the payload up, 600 times. One of those rockets has been reused 32 times. Only one other company has ever done it successfully, and that was Blue Origin. And now Blue Origin and the other major US launch, ULA, are both grounded because of flaws. So right now, the only Western launch company is SpaceX, and they are overwhelmingly using it internally for Starlink. Jet power, how do you overcome Newton's third law of motion and propel something to 17,000 miles an hour, which is what you have to do to escape the Earth's atmosphere, right? And if you think about it, where are almost all rockets launched from? Somewhere near the equator. And they're all launched to the east, because that way you get the 1,000-mile rotation of the Earth as a spin. So that's what you have. This is Blue Origin's. That's what will go up when Starlink, Starship 3 launches is going to be the Raptor. But these are both methane and oxygen, liquid oxygen. Briefly, I won't belabor this, is finance, but there's 3 types of propulsion. Chemical rockets, which is some kind of hydrocarbon or hydrogen, and oxygen explodes and the force propels forward. The second type is hypergolic. I'm a chemist in an earlier life, so forgive me. This is where you bring together 2 highly reactive chemicals, and the force, that's what gives you the propulsion. If you're a historian, the Me-163 German rocket Comet was a rocket engine that uses hypergolic. Many of the fine thrusters that are used in space are hypergolic. And then the ion-powered, this is for long distance. This is where you, very slow acceleration, but can get up to extremely high speeds. If we ever go into deep space, it will be with that. 4 basic types of combustion. One is hydrogen. Everything is something and oxygen. So it's going to be hydrogen is the highest per unit of weight, but it's very hard to use. The SLS rocket that just sent up Artemis 2 was both the first stage and second stage was hydrogen, which is why they had so much trouble, because you have to get it down to 423 degrees, minus 423 degrees to keep it liquid. Absolute zero is 460. It's very hard to use. Most of the ones now use methane, C1H4, and oxygen. Kerosene is another one. That's what Falcon 9, the workhorse SpaceX, is a kerosene oxygen rocket. It's solid fuel. You basically have the oxygen built in with the solid propellant. Almost all military rockets, weapons, are solid fuels, including ICBMs. So that's the basic architecture of how you set it up. If you've studied this at all, heard this at all, you've probably heard Elon Musk quoted as saying, "The best part is no part." Simplify, simplify. These are 3 Raptor engines. The one on the right is what's going up when they do the Raptor 12, Starship 12. Each one of these, Raptor 1, 2, and 3, the 2 was lighter, more powerful than the first. The 3 is the lightest, most powerful of all, and you can see the simplification just graphically there. So this is one of the core tenets of SpaceX. The other is design for manufacturability. They're building over a rocket engine a day. They're building 6 satellites a day. They're building a Starship, when they get up to speed, will do 2 or 3 a week. They're launching spacecraft every 2 or 3 days. So this is a company that's operating a scale that we've never seen before. Launch cost. Up to, the space shuttle was a wonderful machine, but it was a white elephant in terms of the technology. And until that, after the space shuttle ended in 2011, U.S. had no civilian way to get into space. We literally rented Russian rockets to go to the International Space Station until SpaceX came along. But the average cost to send a kilogram of payload to space up till 2011, for the previous 30 years, was $18,500, $18,500. Now, Falcon Heavy could do it for about $1,400. When the Starship actually becomes operational, it's not. Right now, it's still testing out. But when it actually becomes operational, it could be $500 per kilo. Again, historically, this is what's happened over time when sail to steam. When ships went from sail to steam, tremendous increase in efficiency for both commerce and war, reduction in cost, shift from railroads, from horses to railroads and trucks. My favorite are these two. Going to jet propulsion from propellers. That alone caused the number of passenger miles to go from 17 billion to 237, a 15-fold increase in 20 years in the revenue passenger miles from airlines. For going from stevedoring, putting stuff into a cargo hold, to the standardized containers, you had a shift from 717 million to almost 4.7 billion metric tons. Tremendous increase in capacity, reduction in cost. That's what's happening in the space business. SpaceX was started in 2002. The first private satellite launch was in 2009. It first serviced the International Space Station in 2012. First went to delivered crew to the space station in 2020. Now it's embedded. Okay, reusability was first done in 2017. Again, 600 times since then. This is the core piece of their competitive advantage. Okay, satellite economy. There's right now about 12,000 satellites in orbit. We could reach 100,000 easily by 2035, possibly by 2030. This is growing extremely rapidly. Now, very quick, these are the 5 types of orbits. There are 5 orbits for satellites. I need to get over here. The one in the middle, the black one, is low Earth orbit. This is basically, it's like 200 to 1,000 miles, but it's mostly 250 to 550 miles above Earth. Then geostationary orbit is the GEO here. That's 22,300 miles up. What? Well, simple example. I assume that the BBC has their own geostationary satellite above London, and it stays there. So it always circles with the Earth. So you have one space station that 22,000 miles up can cover a tremendous territory. So there's benefits for geostationary. Geosynchronous is the GSO here. This is basically pole to pole, so for Earth observation. And this looks wonky here, but the Earth is actually at a 35-degree angle. It is not, so the pole to pole. And then the one over there, it's called the Molniya for Russian, and if you think about it, it makes perfect sense. You have a very small, at apogee, it's nearest area, but then it goes very high up, so you cover the northern hemisphere 2/3 of the day. It's a very efficient orbit for Russia, Canada to a degree. But the orbits, these are the main orbits. The types of satellites that we have, communications are by far the most common and the most important, at least in terms of economically, of which, of course, Starlink is the dominant source. Earth observation satellites monitor weather, geography, crop yield, the environment. you have navigation and surveillance satellites, and then you have spy satellites, which we know relatively little about. I'll show you a slide on it though. And then science satellites. So these are the 5 types of satellites we have. We will very soon have, was mentioned before, AI. SpaceX has filed for 1 million satellites to be used as data centers. Why? All right. What are the core problems with doing data centers on the Earth? Land, water, electricity. In space, none of these are a problem. You have no land constraint, you don't need water, you're always in the sun, it's very cold. Yeah, this is going to happen. Okay, the benefits. Satellites, all of space, but particularly in satellites, it's easy to see, are dominated by 2 things: Newtonian physics and financial economics. It's always going to be a trade-off of those 2. Low Earth orbit is very efficient. It's close, but there's a problem with low Earth orbit. Well, the benefit of it, the overwhelming benefit of it, is very low latency. If for a geostationary satellite, even at the speed of light, it's over a half a second to send something up and down. So where you have lag, if you've made an international phone call, you know this. With low Earth orbit, it's infinitesimal. You don't notice it at all. So there's a real benefit of that. Requires much less energy to put things in orbit, and the signal from space the strength of the signal declines with the square root of distance. So it becomes very hard to do from space. So there's a lot of benefits for low Earth orbit. The problem, of course, is that they go around the Earth 17 times a day. So every 90 minutes, they circumnavigate the Earth. So for a single spot, to cover a single spot with a low Earth orbit, you have to have a lot of them. And you have to have the ground stations that can track them. So this is kind of the trade-off. The geostationary are much more expensive, but once you get them up there, you minimize the number of ground stations and they stay there. So it's always a trade-off. But the low Earth orbit is overwhelmingly winning, completely dominant now. Only about 10 or 12 geostationary orbits, satellites, are produced every year now. These are the satellite constellations that are planned and actually deployed. And you can see Starlink has over 10,000 actually deployed, operational. They've got 42,000 approved. And then you can see there's about 37,000 for China, of which relatively a handful have been actually put up. And then Project Kuiper is supposed to have 3,200, over 3,000, half of which are supposed to be up by July of this year. They're not going to make it. And then you have a lot of others. Europe has the OneWeb. So you have a lot that are planned, but relatively, except for SpaceX, relatively few that are actually in orbit. Okay, we think of satellites, the communication satellites, as being something the size of a table or a dish. They're not. They're enormous. This is an Optimus robot. We were talking about robotics before. Well, SpaceX, Elon Musk is building 1 billion of these at the Terra factory in Austin. So the Optimus robot is human size. That's the first set that went up with Starlink. The ones the version 3 down here, they wouldn't even fit in this room. Once they're with the wings folded out, with the solar panels folded out, these can only be launched from Starship. So once it goes up, that will be the next phase. But you're going to have 10,000 of these in operation very soon, 42,000 within 5 years. Military sector. Don't want to dwell on it too much, but space has always been militarized. 1,000 years ago, some anonymous Chinese alchemist came up with gunpowder. Within a couple of 100 years, they put it to use in war. The first battle of 1232 was the first use of rockets in combat. The rocket's red glare in the US Star-Spangled Banner was British Congreve rockets, used for 600 years, went out of favor in the 1800s with cannons, much more accurate and efficient shells. But of course, we're in London. They came back with the V2 rocket in World War II, and since then, of course, it's been very much, military has been using rockets to a huge degree. Now, what's the only country that has ever exploded a large nuclear weapon in space? The United States. 1962, summer of 1962, let's go over the Pacific Ocean 250 miles up, explode a nuclear 1.2 megaton, 500 times the Hiroshima bomb, explode a nuclear weapon in space, and see what happens. And of course, you heard of electromagnetic pulse. That's why we know about electromagnetic pulse. Wreaked havoc. It destroyed the first British satellite in orbit. So, yeah, stupid thing to do. We've only done it once, but that's, yeah. That led directly to the Nuclear Test Ban Treaty of 1963. Later, it led to the Outer Space Treaty of 1967. Now, what that treaty did, the Space Treaty, two major things. It prohibited nuclear weapons in space, weapons of mass destruction, which then meant nuclear weapons. And it prohibited appropriating territory. In other words, you could explore the moon and the stars and the asteroids, but you could not claim territory. Country or company could not claim territory. What they left open, because at the time there was no possibility, you can't claim territory, but can you claim the resources? And the analogy would be, nobody can claim, no country or company can claim the ocean other than their continental shelf around them. You can't claim the ocean. But if you find fish there, or you find oil there, or minerals, you can keep that. So that wasn't, still is. That's, internationally, that's still not clear. Okay, GPS, General Global Positioning Satellite System, was done in 1978 for the US military. What really brought it to attention, though, is some of us in the room are old enough to remember KAL Flight 007, which was a 747 that got strayed on the way to Seoul and was shot down by the Russians when it went over the Kamchatka Peninsula. It was off course. And after that, President Reagan, opened the GPS up to first commercial aviation and then to the general public, and the rest is history. These are if you're interested, there's a lot of things that the Space Capital has a very good article. Early adopters, early investors in space companies, GPS companies that went public, had a 690 times return on their investment. This has been where the biggest source of capital has been. Okay, it was first used in a large way militarily in 1991, the Kuwait War, and in 2019, you had the formation of the US Space Force. What you've seen is, of course, this is now absolutely dominant in military affairs. Rockets dominate military capability, and the use, of course, we're seeing this in Iran, we're seeing this in Ukraine, the Golden Dome Defense Shield will be coming. But these have proven, satellites have proven so valuable, of course, that you have to have your own, and you have to have a way to blind the enemy. So this led to anti-satellite technology, which at the early stages was basically shoot a missile at a missile and destroy it. It works, but you have a lot of collateral damage, right? You have a lot of debris being formed. And so one of the things that has happened, let me go ahead and jump to it. This is the volume of space junk. You've probably heard of space debris, space junk. These are things that are at least 4 inches, 100 millimeters in size, that can be tracked from Earth, and there's over 40,000 of them. When did they come about? Well, this is when you had the space test and the satellite test, or the only time there has been a collision in space was 2009. A Russian and an American satellites collided. That's the only time we've ever had any collision in space, and that you can see had a big impact on 2009. Okay, also now, many countries have developed GPS-like systems. Nobody wants to rely on the US, perfectly understandable. So we have the GPS system, but Chinese have Beidou, Russian has GLONASS, India has one, Europe has one. So every country, a major bloc, is developing their own GPS system. And the US, of course, is continually optimizing it. Now, we don't know much about space satellites. The US has a very extensive fleet. The best is called Keyhole 12. Now, what is Keyhole 12? We don't know, but evidence seems to be this is the Hubble telescope, built in the same factory, but where Hubble looks 500 million miles out into space, the Keyhole looks 500 miles down to Earth. This is the only Keyhole satellite photo that's ever been released. It was released by President Trump in 2019 after the Iranians accused the US of destroying their missile launch. But this is extraordinary. You can see the steps. You can see all of the vehicles. If there were people, you could see that. You could see the writing. This is from 500 miles in space, 10 years ago. And by the way, this is a photo of a photo, as you can tell from the flash. So what they can see is absolutely extraordinary. Very quickly, the International Space Station has to be deorbited by 2031. It was supposed to be deorbited in 2024. There are several companies competing to try to develop a private space station. NASA does not want to build their own. They want to be an anchor tenant, but not actually have the government own it. It may not happen. There are real problems with the economics. So if I was a betting person, I'd bet $1 that probably is not going to happen. But it's still, $4 billion has been invested in private space companies. So we'll see if it goes on. All right, the moon and Mars. Why are we going to the moon or Mars? I don't know. I mean, it really doesn't make any sense economically, but we have some very powerful people who are paying for us to do it. Of course, by far the driving force is Elon Musk, who's famously quoted as saying, he wants to die on Mars, not on impact. Right? So he wants to build 100,000 people there in a colony and become the first governor. Now off you go. The moon is a wretched place. It's a barren rock. It has 25 trillionth the atmosphere of Earth, a sixth of the gravity, tremendous temperature variations. The ground, the dust is terrible, sharp, magnetically charged, and you have 14 days, 14 nights. No radiation shielding. Why are we going there? There are no resources there. There are no little green people to convert, and all the reasons that we've explored in the past. But we're going, and we're racing China to get there. So one way or the other, we're going to the moon. All right. Financial returns. So far, they've generally been pretty bad. This was an index that was started for the new space. These were mostly the SPACs that went public in 2020, 21. Earlier, talking about that being a special time. Well, you had a wave of 9 or 10 space companies went through SPACs in 2020, 21. And that's the light blue there. They did terribly until last year. Since then, they've come back. The others are the S&P 500 and traditional aviation companies who've done fairly well. So now the Rocket Labs has quadrupled last year. As we can see, this is SpaceX, this financing of SpaceX. 28 private financing rounds. So they rose steadily until 2020, and then you can see it goes up. And the valuations quite literally tripled between the fourth quarter of 2024 and the first quarter of 2026. They're planning an IPO, 75 billion with a $2 trillion valuation. This is a monster of a company. And off you go. Okay, I'll conclude with this. What's the future of the space? Well, it's going to grow. And if you've watched this at all, you've probably seen something from the World Economic Forum, or the space industry is going to reach 1.8 trillion by 2035. This is where it comes from. This is an article by McKinsey and World Economic Forum. Excellent. I refer to you if you're interested. They basically break it down into backbone stuff that you would normally associate with space, launchers, satellites, things, and the reach is the applications of those. And they're going to go from 630 billion to a projected 1.8 trillion. Okay, what is the future? What's a viable business? Is space mining a viable business? No. Except in the very long term. Once we're on Mars, converting the CO2 on Mars into rocket fuel, maybe. In the short term, almost all of the mining will be for water. Water in space is far more valuable than gold. You can use it for cooling, you can use it for consumption, you can break it down into hydrogen and oxygen. So space mining in the intermediate term will happen. Short term, no, it will only be for water. Who wants to be a space tourist? I don't, but a lot of people will. This will be a small but niche and growing area. As a thought process, not tourism as much, but think of it as the woman who will be the mother of the first baby born in space. Is she alive today? And if so, is she Chinese or American? I think she is. I think she's in high school at least. It will happen. Everything that's done on Earth eventually will be done in space. Okay, manufacturing and research. Yeah, and a lot of research, really cool stuff's going on the International Space Station, but why would you manufacture there? There's no gravity, right? You can have perfect spheres. Crystals grow perfectly. Essentially, almost everything that can be manufactured would be much more efficient done on Earth. But if we're going to the moon and we need an architecture, infrastructure, some of that will be created in space. Now, space debris. I'm out of time, so I'll go through this quickly. But you hear a lot about this. And you see images like this and think, oh my God, this is terrible. You're going to have collisions, and once a nuclear weapon or a nuclear reaction, you have one hitting another and they all go and propagate. Well, it's only happened once. And, 200 to 500 miles over the entire Earth is a big territory. But yeah, this is a problem. I don't think there's a business solution. It will be regulation. And already, you have to deorbit satellites after 5 years. Okay, finally, this is probably the case. There will be transportation. If you have 100,000 satellites, they'll need to be serviced. There'll be lunar base Alpha will be built and service everything to go there. 1,000 starships. This is going to be the critical test either this year or next. Can SpaceX send a starship up, rendezvous, and transfer fuel? You can't get to the moon without doing that, and that has never been done. The US military is absolutely fascinated by this. In fact, they want to buy 12 of them. Normally, they just buy the service. The idea being, it would be kind of nice to have something where you could take weapons or humanitarian supplies and get from Florida to Tokyo or Korea in 45 minutes. And this can. Like really expensive FedEx. So this might have a future. But whatever happens, the conclusion, the future of business is in space. Now, the Space Capital has an article, SpaceX is the most important company in the world. I highly recommend it because, it's kind of persuasive. Thank you very much. It's been a pleasure.